We're not actually going to solve these equations. We're going to figure out how many distinct solutions they have and what type of numbers those solutions are. We're going to do that using this special value called the discriminant. So the discriminant of a quadratic is b squared minus 4ac. It is the part inside of your radical in the quadratic formula, which, if you think about it, the value inside of that square root determines what type of numbers your solutions are. Because your coefficients on your quadratic are all rational real numbers, so it's whether you get a positive or negative or perfect square for your b squared minus 4ac part that determines what kind of number your solutions are. So let's look at that on this one right here. So if I just ignore everything else from the quadratic formula except the discriminant and plug my values in, I'm going to end up with 84 for my discriminant inside of my radical. Now, square root of 84 isn't a perfect square. Square root of 84 is an irrational number, which means that I'm going to have two irrational solutions for this equation. There's two of them because, don't forget, you have the plus or minus, so I have some values, plus my square root of 84, and then a different solution from those values, minus square root of 84. If we look at another one, get 0 on one side first, and then my discriminant would be inside my radical, negative 10 squared minus 4 times 1 times 25, which is just going to give me 0. So 0 is a perfect square. Square root of 0 is just 0. So I'm going to have my value plus or minus 0 all over 2a. So that's going to give me one rational solution. There's just one because if you add 0 or subtract 0, you get the same value. If it was a perfect square that wasn't 0, like plus or minus square root of 4, then you just have two rational solutions. If I look at this last one, for my discriminant, I'm going to end up with negative 7, which means that I am going to have imaginary value involved in my solution. So I'm going to have two non-real complex solutions. We've talked about solving quadratics by factoring and by completing the square. The last method we're going to look at is using the quadratic formula, which comes from completing the square. So if you remember your quadratic formula, it's x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Yay, you guys love my singing, I know. So we're going to solve this one. First thing you always need to do when using the quadratic formula is get 0 on one side of your equation. So we're going to add 2 to both sides. And then identify your values for a, b, and c. Be careful if your equation's out of order. A is the coefficient on x squared, b is the coefficient on x, c is your constant. And then we're going to plug those values into our quadratic formula. So when you do it for these, it's going to give you opposite of negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 2 all over 2 times 1. And then I simplify inside the radical first. Definitely would recommend starting there. So on this one, you're going to have negative 4 squared is 16 minus 8. So you'll have 8 inside your radical, which you can break down square root of 8 into 2 square root 2. So break down, simplify your radical first, and then see if there's anything else you can do. So we'll end up with 4 plus or minus 2 square root 2 all over 2. And then if you look at that, we can reduce our fraction because 4, 2, and 2 all have a common factor of 2. So if I divide everything by 2, I get 2 plus or minus just 1 square root 2, or 2 plus or minus square root of 2. I'm going to tack on one more here that I forgot we needed to talk about. We're going to solve x cubed minus 8 equals 0, which isn't quadratic, but if you think about solving it, you might be tempted to add 8, take the cube root of both sides. You'll get a solution if you do that, but there are actually 3 solutions for any cubic, x to the third, 4 for any x to the fourth, 5 for any x to the fifth. So this is how we're going to get all 3 solutions, both our real one and our complex ones. And to do that, we are going to go back and use our factoring skills. So if I factor this, I want to think about what I'm cubing to get x and what I'm cubing to get 8. So 8 is 2 to the third. And then if I factor it, I'm going to have a binomial and a trinomial. So like drop off my cubes, just have x minus 2. And then in my trinomial, I have my x squared. And then my last term is going to be 2 squared. My middle term comes from multiplying 2 and x together. My signs are same, opposite, and always plus. And then if you think about the fact that this cubic is set equal to 0, I could easily just set each factor equal to 0, and for x minus 2 being equal to 0, I just have x equals 2, so that is the one real solution that you have. For my other factor, I can't solve that by factoring. I'm going to have to either use the quadratic formula, or actually I'm going to complete the square, because this one would be pretty nice to complete the square on. So 4 is the wrong value to complete the square. If I cut the 2 in half and then multiply it times itself, if I add 1 to complete my square to both sides, then I can rewrite it as x plus 1 squared equals negative 3. Take the square root of both sides. You'll have x plus 1 equals plus or minus, make that I square root 3, and subtract 1 from both sides. X equals negative 1 plus or minus I times the square root of 3.